All right, guys, we're going to talk a little bit about matrices, and this is not going to be on any of our major assessments in terms of the test for Unit 3 coming up, but we're going to get you used to working with matrices, and then we'll use them to actually solve a system in a different way than you're used to, okay? So it's a way to kind of store data elements that you'll see here. These examples of matrices, you have matrix A, matrix B, and matrix C. And the way we identify them, not only by the letter, but we focus on the rows and the columns of a matrix. So it's always rows by columns. All right, so rows are your horizontal, right, or left to right. And columns are vertical or up and down. Okay, so in this first matrix A, this has 2 rows by 3 columns. For matrix B, that has 3 rows by 2 columns. And matrix C has 3 rows by 1 column. All right, so that's how we do, how we notify or identify the dimensions of a matrix. A couple of questions here, you can probably figure them out. Square matrices, they have the same number of rows by columns. So we have 2 by 2 here. This is 4 rows by 4 columns and 3 rows by 3 columns. Row matrices, they only have 1 row. So you've got a 1 by 2, a 1 by 5, a 1 by 4. Column matrices, they only have 1 column. All right, so that one's a 5 by 1, a 4 by 1, a 3 by 1. And then zero matrices, all right, it's in the name, right? All of your actual values in the matrix are going to be zeros. Okay, so a couple of things can be true if you have each corresponding element that's in the same location would be equal. So like in this first one, we have a 2 by 2 matrix set equal to the exact same 2 by 2 matrix. So that will be true. The one to the right is not true because the numbers are not in the exact same location. And then for this third one, with the m and the n, what we can do is we can actually set this m plus n equal to 5, and then we can set 3 equal to m minus n, and that is actually a system. And we can solve that with the ways we were doing before. I don't know why I wrote 2, apologize on that. That should be n, my bad. There we go. And you can see if you were to add right now, you would eliminate one of our variables, that n. So you get 2m equals 8 or m equals 4. Plugging back into the first one, you get 4 plus n equals 5, so n equals 1. You could plug back in to make sure that's true, right? 4 plus 1 is 5, so the highlighted in pink is true, and then 4 minus 1 is 3, so the highlighted in yellow is also true. All right, can't do that one on the right side because we don't have the same dimensions with x and y and 1, 4, and 0, so not able to do anything with that because they don't have the same dimensions. Okay, so the most basic operations with matrices is going to be adding and subtracting. And the key thing you have to remember for adding and subtracting is they have to have the same dimensions, right? So you're thinking the same rows by columns. If they don't have the same rows by columns, then you're not actually able to do it. So we write not possible, right? So if you look at this first one, right, because we have a 2 by 2 matrix and a 2 by 2 matrix, we can actually add these matrices together. Now, because with addition and subtraction, they have to have the same exact dimensions, we know that our answer to this is also going to have the same dimensions. So what you do is you just add the numbers that are in the same location. So 5 and -4 will be added together, -6 and 6, 8 and 8, and then finally 9 and -3. All right, those are all in the same location, so we add those together. So we get 1, 0, 16, and 6. All right, and that's how you add matrices. All right, if you want to do part B, or letter B here, you could do subtraction with this, and this is what is called a row matrix because we only have 1 row. So this is 1 row by 3 columns for both of them. So our solution will be 1 row by 3 columns. You don't have to make those little kind of placeholders like I do. It's just out of old habit of doing this for so many years, especially when we talk about multiplication in class. If you're going to do, especially if you're going to do multiplication by hand, I'd highly encourage you using the placeholders. But again, not a huge deal if you don't. So 8 minus 3 is 5. 6 minus 5 is 1. -4 minus -8 is actually -4 plus 8, which is 4. All right, I'm not going to do C or D, but you definitely could do those because they have the same dimensions. But if you look at part E, you would notice that our A matrix is 2 by 2, 2 rows by 2 columns, and our B matrix is a 2 by 3 matrix. Now those dimensions are not exactly the same, so if they're trying to have you add A plus B, this would be not possible. The dimensions have to be the same. Okay, so that's kind of a quick little overview on adding and subtracting matrices. Now, there's kind of two ways that we multiply with matrices. One of the first ways we'll go over is called scalar multiplication. So a scalar product, which just means that you have this number in front that you're going to multiply every single term or element that's in the matrix by that value. So we would just multiply all of these by 5 to get 10, -15, 0, and 20. Okay, I'm going to skip B and go to C just because it has a fraction. So multiplying all 4 of these by 3/4 is going to be 15, 27, what's that, 9, and then -12. Okay, so that's how we do the scalar products. All right, now this part D, if it throws that negative sign in front of that matrix A, all that means is you're going to take every single element in matrix A and make it the opposite, or multiply by a -1. So all 6 values will become the opposite. All right, so that's just be ready for that when you do some subtraction. Okay, so I'm going to do part A here to kind of put some things together that we've done. I'll do C as well. So when you look at part A, you can see that they're both 2 by 2 matrices. So I can set, if I wanted to solve for these unknowns, I can set -2x equal to -8. And then I can also set 3y equal to -12 to solve for x and y. So let's do that. And then 3y equals -12. So x is equal to 4 and y equals -4. All right, for C, a little bit tricky here because we're solving for that x. I'm going to actually take this matrix here that's on that same side and subtract it to the other side. So I'm going to subtract that entire matrix to move it to the right side. Okay, so I subtracted it over there, and I'm actually going to just bring this down. So coming down then is the 2x because I've moved that matrix over. And then if I were to subtract those values in those matrices, I have -2 minus -1, which is really adding 1. So that's going to be -1. 5 minus 3 is 2. Then I have 4 minus 0 is 4. And 3 minus 7 is -4. Now to solve for x, ultimately I need to move that 2 to the other side with division. So I don't really want to write this divided by 2. But hopefully you guys remember from middle school or even early high school that if you divide by 2, that's the same as multiplying by 1/2. So actually, if I do a scalar product and multiply every single value in this matrix by a half, or cut it in half or divide by 2, then I will get the value for x. So my x matrix is going to be -0.5, 1, 2, and -2. Again, not really worried about like all the reasoning there, just making sure you feel comfortable with incorporating some algebra, some scalar products. Okay, now just a quick little brief thing about multiplying matrices, and we'll do, maybe one, definitely one, at most 2 multiplying by hand. But since we have calculators, I will show you guys how to do this in the calculator. But I do want to show you by hand at least once so you know what the calculator is doing. And the way this works is you're going to do the same thing as if it were adding or subtracting. You're going to focus on the dimensions, but the dimensions are different, or I should say the rules are different for being able to multiply from adding and subtracting. So with adding and subtracting is very straightforward. The dimensions have to be exactly the same. If your dimensions are exactly the same, you definitely can multiply, but the things that have to be the same are the middle dimensions when you line them up. So what I mean by that is the columns of the first matrix in your multiplication has to be equal to the rows of the second matrix that you're multiplying. So let's just do one for example. So if I were to write down, and I'm not going to walk through the whole thing on this video, There's so many videos out there where you can multiply by matrices. I definitely have them if you find, if you go through my playlist or just search. But I just want to see if this is even possible to do. So A times B. So write down the dimensions. This matrix A is a 2 by 2 matrix. This matrix B is 2 rows by 4 columns. And what you want to do is you want to underline the inside numbers. All right, so I said this earlier. That's the columns of the first one and the rows of the second. Those are the same. They're both 2. So because those are equal, this is possible. And the numbers that you didn't underline, the first and the last ones, that gives you the dimensions for your actual product matrix or your answer. So our answer is going to be a 2 by 4 matrix. Again, I'm not going to do that right now. There's probably need more room. There's not a ton of space here. But that is how we would do this, or for the setup. Let me quickly show you if you did B times A. So I'm going to change the order. So write 1, 0, -1 and 2, 3, 1, 4, and -1 times matrix A, which is 1, -3, 7, and 2. All right, so we already know the dimensions, right? We just did this. This one is a 2 by 4 matrix. This one is 2 by 2. Underline the middle numbers. All right, out of those 4, those are the middle 2 numbers. And you should notice 4 and 2 are not the same. So this is not possible. And I'll show you, in more greater detail in class. But the idea is that if those numbers are not equal, then we are not able to multiply these 2 matrices. So we write not possible. So one thing you should notice is that it's no guarantee that if you're able to multiply 2 matrices together, that if you change the order, right, we call it the commutative property when it's like regular multiplication, right? 3 times 9, 9 times 3 is the same thing. That's not true for matrices. They don't follow those same properties. So you have to actually write it out and see if it's even possible before you multiply. Okay? Again, we'll do one in class to make sure we know how to do it. All right? Okay, so there's some steps here at the bottom. If you want to take a look at those, again, we'll go over it in class to make sure you know how to do this on the calculator. And we'll do one by hand to make sure you know what the calculator is actually doing. All right, so don't forget to try the homework. Come see me for office hours if you have any questions about matrices. Good luck.